All right, moving on to section 9.6, inverse and graphing logarithmic functions. So we're going to find inverses and then hopefully be able to graph log functions. So just to really quickly evaluate without using a calculator, so we want to know what log base 4 of 16 equals. We'll just say it equals x for now. So rewriting this would give me 4 to the x power equals 16. This one should be pretty straightforward. Hopefully know that x would be 2. 4 to the second power is 16. Log base 2 of 8 equals what? So 2 to the x power equals 8. Again, hopefully you know it's pretty straightforward. X would equal 3. 2 to the third power is 8. So log base 8 of 2, so we switch the base and that number around, equals what? So 8 to the what power gives me 2. So just a reminder that anytime you're going from a big number to a smaller number, your exponent there is going to be a fraction. So you kind of want to think about it backwards. So 2 to the what power would be 8. We just did that one. That means x would be 3. So if I want to go the other way, like right here, from 8 to the what power equals 2, I would just make this a fraction. I would flip it to its reciprocal, so 1 over 3. So that means x equals 1 over 3, 1/3 power. Log base 4 of a half equals x, so 4 to the what power equals 1/2. Same thing, you're going from a big number to a small number. So you'd say 1/2 to the what power equals 4. So in order to go from a fraction to a whole number, you have to have a negative exponent. So 1/2 to the negative and then 2, because 2 times 2 would be 4. So kind of a long way around here. But this right here is the opposite of this, which means that if I want to go from 4 to 1/2, I need to take my exponent and flip it to its reciprocal. So the reciprocal of negative 2 would be negative 1/2. All right, and we'll skip this one here so we can continue to move on. So log inverses. So one thing right here is the key that you need to know. Log functions and exponential functions, they undo each other. So for example, I have 10 to the log of x. Again, just a reminder, anytime you don't see a base written here, it's assumed that it's 10. And anytime the base of your exponent and the base of your log match, they cancel each other out, and it leaves you with just x. Log base 5 of 125. So what we could do is just rewrite this because I want a similar situation. I want my base and the number here to be the same if I can. So we could write this as log base 5 of 5 to the third, because that's 125 is 5 to the third, and then I can't forget about this x here. So now my base and this number are the same, so that means that everything here cancels out, and it leaves me with just 3x. Okay, so that just shows you that they are inverses, they undo each other. So now we're going to find some inverses. So find the inverse of the functions. We've done this before with exponential equations. It's the same process here. So first we want to switch x and y. So x equals log base 8 of y. Then we want to rewrite as an exponent. So you start with your base, so 8 to the x power equals the number after your log, or in this case the variable, equals y. There's your inverse. So if we try another one, we have x equals the natural log of y minus 3. So we want to rewrite this as an exponent. Now, this is going to be a good refresher for you. So you start with your base here. If it's not written and it is a natural log, which we have, that means our base there is e. So we have e to the x power equals, and then the number or variable following your log, which is y minus 3. And then just like before, if you have a situation where you don't have y by itself like we did here, you need to solve for y, so it would be one step. We'll add 3 to both sides, so e to the x plus 3 equals y. There would be your inverse. So, a couple more here. I'm not going to do all of these, but I'll kind of maybe just go down the left side. Well, there are some good ones here. I'll do a couple. So, first thing, switch x and y. So, x equals log base 9 of y, and then rewrite it as an exponent. So, hopefully by now we're becoming almost experts at converting logs to exponents and vice versa. So, you take your base 9 to the x power equals y. Y is by itself. There's your inverse. Now over here, what we want to do is switch x and y. Switch x and y. Log base 7 of 49y. Now we're going to rewrite this as, so I'm going to have to do some highlighting here. So 7 to the x power equals 49y, whatever number is following your log. Goodness. So now we could potentially write these. So now we have to solve for y. So this trick we actually had to use last unit, but I want these bases to be the same. So instead of 49, I could write it as 7 squared. 7 squared is 49. And then again, don't forget about that y. So 7 to the x equals 7 to the 2y. If you get this situation, we'll get into solving more, so it's kind of a lot happening here. But we'll get into solving more. If your bases are the same, you can just set the exponents equal to each other. Again, we're trying to solve for y. Divide both sides by 2. And there you go. So I'll do just one more. I'll save the rest for you. So start again by switching x and y. So x equals log base 1/2 of y. So that means that 1/2 to the x power equals y. Y is by itself. There's your inverse. So there's 3 more there for you to do, but let's talk about graphing here really quickly. The graph of our log function has the following characteristics. It has a vertical asymptote where our h value is. So I'm going to highlight this. I should highlight this first. This is our generic form. We have the h and k thing going on. Where h is our vertical asymptote. The domain always has to be greater than h, and the range is going to be all real numbers. So kind of the opposite of what we were graphing just recently, where your domain was all real numbers and your range was dependent on k. Here, our domain is dependent on h, and our range is all real numbers. If your base is greater than 1, it's going up and to the right. If your base is between 1 and 0, so like 1/2 or 2/3, for example, it's going to go down and to the right. All right, so graphing log functions. So the first thing you want to do is find your shift. So we really don't have anything labeled here, so I'll write it in, our shift. So you're looking up here, you're looking for h and k. So if I were to put parentheses here, there is no h value, and there's nothing out back here, so there is no k. So our shift is 0, 0, so we don't have to worry about anything there. Okay, now we want to take this and rewrite as an exponent. So we'll go 1 here, we'll go shift, and then 2, exponents. So log base 3, now this can be confusing, but f of x is the same thing as y. So you have y equals log base 3 of x. So rewrite it as an exponent because we can plug numbers into exponents and it makes sense. Logs maybe not quite so much right now. What in the world? I apologize. I'm not sure what's happening with this. All right, so there's our shift. If I rewrite this as an exponent, I would say that 3 to the y equals x. Okay, so then what we're going to do is we're going to, actually, this is kind of opposite of what you would imagine. We're going to pick y values to plug in for our exponents. Easier to work this way, I think. So we're going to pick values for y. And we should probably have at least 5. So like -2, -1, 0, 1, and 2. Because here we don't have to worry about limitations for our range. Our domain, though, we do have to worry. So if you plug these in, we're going to start by saying 3 to the -2 power equals what? What will we get out for x? We've done this a number of times, but 3 to the -2 is the same thing as 1/3 to the +2 or 1/9. Okay, if you plug -1 in again, so now I'm going to erase that there. Do the same thing, but you're going to say 3 to the -1 equals what? That'd be 1/3. Anything to the 0 power is 1. 3 to the +1 is 3. And 3 to the +2 is 9. So then, again, from your shift, you're plotting those points. So we're going to start with our first point here. We're going to go from the origin, because that's our shift. We're going to go to the right 1/9 and down 2, so somewhere right there. We're going to go back to the origin. We're going to go to the right 1/3 and down 1, so something like that. When you get to those fractions, it's not going to be 100% accurate. That's got to be okay. And then we're going to go to the right 1, down 0, and then to the right 3, up 1, and to the right 9, up 2. So 2, 4, 6, 8, 9, up 2. So here would be the graph of your log function. Now, I mentioned it up here, but we have a vertical asymptote at h. So our vertical asymptote would be x equals our h value we said was 0. So that means that vertical line, I'll highlight it right here, color it in. It's never going to cross this vertical line. All right, so let's do another. Graph the function, state the domain and range this time. Okay. I guess the last one also said that. So first, again, you want to start with identifying the shift. Actually, let's see if I can find one with a shift. Here we go. Same thing. Graph the function, state the domain and range. So again, start by identifying your shift. So I'll just write that down. It comes from h and k. But remember with h, you're going to have to flip that sign. So it's going to happen at 3, 1. So I'm going to plot that point there. Now, we talked about shifts earlier this unit, and it was kind of confusing. So if you would like, through that point, what you're doing is you're shifting the origin. So you're taking this point here and you're moving it there. That's what's happening. So what you can do is make a new y-axis, if you'd like. You know, make it dashed or solid. It's up to you. There's my new y-axis. Here's my new x-axis. So you can avoid the confusion if you'd like. If you're okay plotting it off that one point, then that's fine too. So identify your shift. Perfect. Then we take our equation. Okay, let me explain something. Once you graph your shift, what's happening is we're ignoring this and this now. So we're looking at that equation. I'm going to leave mine erased. What in the world? You probably want to erase that scribbling. I'm going to leave mine as scribbled. You probably want to erase yours. Sorry. It's throwing me off here. All right. So once you graph your shift, you can forget about h and k. They don't exist as part of the equation anymore. They don't affect anything that we're about to do. So now what we want to do is write what's left as an exponent. So we want to go to exponent form. So that means that 4 to the y power equals x. And that's it. Like I said, you forget about h and k when you do that. Then you make your table. And now this time, like I said, it's backwards from everything we've done graphing up until this point, in Algebra 1 or Algebra 2 or whatever, but you pick the y values, and to keep it the same, we're always going to go -2, -1, 0, 1, and 2. The reason, again, is because it's easier to plug them in as an exponent and then figure out what we're going to get for x rather than pick x values and work it backwards to figure out what y would be. It's less of a puzzle that way. So here we go. 4 to the -2 would be 1 over 16. 4 to the -1 would be 1 over 4. Anything to the 0 power is 1. 4 to the first is 4. And 4 squared is 16. So there you go. Plot your points from our shift again right here. So I put the new x and y axis on there to maybe make it a little less confusing. But here we go. So we're going to go to the right 1/16 down 2. So that's going to be like right there. Then I'm going to go to the right 1/4 down 1. So something like that. Then to the right 1 down nothing, down 0. Then I'm going to go to the right 4, up 1, right there. And then I'd go to the right 16 and up 2 if I could. But obviously it's not going to fit. It's going to be somewhere way out here. And there you go. So let's talk domain and range. My domain, actually start with the range. The range is always all real numbers for log functions. Any log function, you're going to get out any real number. But what you plug into these functions is going to be limited. It's always going to be x is greater than, and then the number here is going to be your h. So in this case, I highlighted it with a very similar color, so let's maybe pick a different one. I don't know. H is 3, therefore we're going to say that x is greater than 3. It's always your h value. And there you go. I know there's a few more, but go ahead, give those a shot. Get a little more practice, and that takes care of section